Okay, we're going to continue on with Unit 3, Section 1. We're going to start off Part 3, how do crystals form? So first we're going to talk about general ways, what actually happens molecular-wise, and then we're going to talk about the three different ways that we can make them from a solution. So first thing you need to know, all crystals do come from a solution. They start with a process called nucleation. Okay, nucleation, and there's a small center for everything to begin. There are two ways that crystals can form. Either it could be unassisted or assisted. Unassisted will cover first. The molecules start by themselves, and there's a little guide picture over here to what's happening as we talk about it. So first step, molecules meet each other and they bond together. Okay, they just happen to bump into each other. Okay, they can stay together, they can break apart. Eventually, though, there's going to be enough of them, okay, a certain number of molecules, their critical size, they stick together and they can't be broken apart. Okay, so three molecules happen to bump into each other, a fourth one comes along, and before they can break up, a fifth one, and now they're big enough that after they're too tight, they can't get away from each other. Okay, so that's their critical size. Starts off. They begin to bond with each other, and they become what we call a protocrystal. So it's not quite a crystal. Okay, it's the beginning of it, but it's definitely a section that will continue going. You can see right here, it's a little, it's like one of the four sides of a wall. Okay, protocrystals become the nucleation site for other molecules, and eventually we begin that big process of having a complete unit cell and building other unit cells on them. So that's unassisted. In other words, they just happen to bump into each other and we get a crystal growing. So pure luck. The other way is assisted. Okay, basically assisted, it comes to help some solid matter that's already there. This is how we actually make rock candy, and this is your picture there. Okay, they make rock candy using a string, or usually in this case a wooden stick, to act as a place for those crystals to come together and meet anyways. So they're basically a surface for the molecules to meet. So we have unassisted and assisted, and you're going to be seeing both in your different labs. Your single crystal, your copper crystal, is going to be assisted, okay, because you have that seed crystal, and we'll get to what a seed crystal is. Or you have unassisted, which is your solicitate that you'll be doing from a melt. So we'll talk about that more in a little bit. So assisted and unassisted. There are three major forms that a crystal can take. Again, it has to come from a solution, okay, coming from a liquid. They can either come from a melt, come from a precipitate, or come from a supersaturated solution. So let's talk about the melt first. So first step, cooling, liquefy, or melt. If it's slow cooling, what do we get? So it's cooling, they can get bigger. So we have large crystals. Fast cooling creates small crystals. And we talked about that already with the rocks. So that's a great example of cooling from a melt. Another one would be frost. Okay. What else? We will see in this lab the siliconic acid under the Mason microscope. And of course, I forgot that this is silly, metals. This is how we have a liquefied metal, let it sit. So obviously the bismuth crystal that you know so well now comes from the melt. Okay. Another way we can do it is grown from a precipitate. Okay, a precipitate is a chemical reactions. You're going to do it with copper and silver nitrate underneath the microscope. Okay, basically it's a chemical reaction where two solutions are combined and they come together to create a new product. It's actually have a quick video to show you for that. And this is something called Golden Rain, and you can sort of see why. But what's happening is you have two solutions coming together, and they create a solid. The two solutions form a new chemical reaction and a double displacement reaction, and you have this beautiful golden rain happening. Okay. Let's go a little bit. Let's speed it up a little bit here so you can see it. Slowly, and then it gets a little bit better. So you can see the crystals. You can see how they're reflecting that light because of those flat faces. Again, this is a precipitate. It's a solid coming from two solutions coming together. So it seems to come out of thin air like rain. So you have the golden rain. Isn't it beautiful? I love it. I'd love to do this one for you guys, but we don't store the chemicals needed for this because there is a big safety concern. Some chemistry teachers might do it, but we don't do it at Pioneer. So we'll just watch YouTube videos. All right, let's go ahead and go back. That was forming from a from a precipitate that is again called golden rain. Okay, so that's another example for you. And then the last one, which is probably the most common, I think, and this is what you're going to see most often in lab, is the solution where the solvent cools or evaporates. This is coming from a supersaturated solution. Okay, examples of this would be your copper sulfate crystal. Okay, the Nika cave crystals. These are coming from that solution. Okay, geodes are another. I'm going to look at this. Geodes are another example. Okay, you're going to make borax crystals. Those are coming from a supersaturated solution. Salt. When the ocean water evaporates, it leaves salt behind. That's exactly how we get salt. The really cool thing is you're going to get a chance to do some extra credit later in the unit, and there it looks at these different types of crystals, how they're formed, and so you'll be able to see all of these different things. So when I talk about a supersaturated solution, what is it? Well, let's talk about what a solution is first, okay? This is a term you should probably be so familiar with. This is probably review for you, okay? But a solution is a homogeneous mixture. In other words, these things are not bonded together. You're not breaking them. They can separate easily, and that's actually what we're doing, is separating them out, okay? So basically one material is dissolved into another. You have your solute, okay? That's the solid material that gets dissolved, and your solvent is what does the dissolving. So water is like the universal solvent. It dissolves most things, okay, in there. So as you can see from your little picture that you have in your notes, solid getting a liquid makes a solution like salt water, sugar water. This is your Kool-Aid there. Okay. Now there are different types of solutions, and it does depend on what you have. The first solution is this unsaturated solution, one type of solution. That's if you have you can add more solid to your solution. This picture is an example of the copper sulfate that we're using in our single crystal lab. Notice that it's not very dark. We can add more and there wouldn't be any problem. It would all dissolve. Okay, so if we add more, it'll all dissolve. Saturated means that no more solution can be dissolved. It has as much copper sulfate in that water as it can stand. Nothing else is going to get in there. Okay. The last type, supersaturated solution, it holds more solvent than it can normally hold. In other words, there's actually extra in there. Okay. So how do we do that? You guys didn't have to do it. I've been doing it for you, and this is how I do it and why I do it. So you actually have to heat it up, okay? If you heat them up, a solution can hold more solute. It gets higher temperatures, more movement, more can be dissolved, okay? You heat the solution up, add more solute, add more copper sulfate to it, and then let the solution cool. So as you let it cool, it sort of hang on to it, and it'll keep it there without a problem. Eventually, though, what will start to happen is that you will have crystals growing on the bottom of this as that extra copper sulfate comes out. So we have to be very careful when we're growing our crystals to use a solution. We want a supersaturated solution. So I go ahead and make it. And we have to let it cool before we pour it into our copper sulfate with our copper sulfate crystals in our cups. Because if it's still hot, what can actually happen is it can actually reverse and dissolve the crystal and take it away instead of adding it to like we want it to. Okay. If we use just a saturated solution, then nothing would happen. Our crystal would stay the same size. But if we use a saturated solution, that would also dissolve our crystal because the crystal would want to be in the water and not remain in its crystal seed form. So supersaturated, all that extra will build up onto our crystal, and that's where we're getting the material to make our crystal bigger. One last thing, speaking of crystal, we talked about seed crystal. Seed crystals, they're actually formed from a solution as it evaporates. Okay, when we're done with our stuff, I'll pour it into a tin, let it sit for a couple of days, and let the water evaporate out, leaving behind that copper sulfate, and it will again nucleate, okay, unassisted nucleation, and start to form those seed crystals. Okay, so we did use a seed crystal to start our copper sulfate. Again, solutions must be saturated to start a crystal, otherwise they would just dissolve. And actually, they need to be to start a crystal saturated. If we want to grow a crystal, they need to make it bigger. We need to have it super saturated. Put it over here. So I hope that answers any questions for you, and have a good one.